Good evening, everyone. My name is Ali. And in the past few days or weeks, I've been working on developing an intelligent pronunciation tutor, which I call as Pronounc AI, a fancy name because why not? Uh, so let's have a look at the problem statement first. So almost everyone sitting here will be familiar with this problem that when we are learning a new language, so once we are learning a new language, then mastering the sounds or phonemes, which are the basic constituents of speech, it can be tough, right? Because we speak different languages. So to improve the pronunciations, from what I know, there are two most common solutions. So either you can hire somebody who is a pronunciation expert, so he can give you very personalized and expert feedback. However, this guy is going to cost you a lot of money. And because of this reason, this option is already out of range for most of us. When it comes to the other option, which is the language applications like Duolingo and so on, then this is, of course, more affordable. However, the feedback that we get from these applications, it's, in my opinion, very vague. They just give you a score in terms of numbers based on your pronunciation of a sentence. However, you really don't know what is wrong and how you can improve it. So most of the time, learners are left guessing what to fix and how to fix. So this is the problem that I identified and tried to come up with a solution using machine learning and AI. So Pronounc AI is a platform which basically tries to solve this problem. And this platform has been developed using this pipeline where, of course, it's about machine learning. So you need to have some kind of a data set. So the data set I have used is from L2 Arctic corpus website. So this data set contains the recordings as well as the feedback from the experts based on the pronunciations of the speakers, if they have pronounced it correctly or incorrectly. So they have really resolved this feedback at the phoneme level of the sentence. So this is the data set. Then this data set goes to a pre-processing step where the outliers, noise, etc. is removed. And afterwards, it goes to a feature extraction pipeline where basically the recordings are converted into numbers. I mean, we all know that sound waves can be represented in terms of numbers, so it's not something new. So after having this numeric representation of the recordings, it goes to a wave LM base plus transformer, which is one of the famous NLP transformers we have. So this is used to basically generate the meanings or the embeddings of the audios of the recordings in terms of the phonemes. Yeah, and then afterwards, a neural network classifier is built on top of it. So this basically predicts the phonemes that are there in the actual in the recording. So not the theoretical ones which would have been, but the actual ones. And the data about the theoretical ones, it's coming from the data set that we have initially. So once the training has been done, then this can be fed to an LLM, which can give us feedback based on theoretical one versus the actual one. And this detailed report analysis can be then visualized on Streamlit user interface, which is quite nice. So we can further look into these blocks. So for the first two, the data set has in total 24 different speakers, and each speaker records 150 sentences. And this is how it looks like. So this is like a sound wave. And then, for instance, the sentence is, "She had your dark suit." So then for this sentence, you see the phonetic level resolution of the sentence. So these are the phonemes. So in case they are right, so the theoretical one is equals to the actual one. However, in case there is a mispronunciation, then the experts mentioned that this should have been AO, for instance, should have been the theoretical one. However, the one that the speaker pronounced was AA, so there's a mispronunciation. In the pre-processing step, what happens is basically I parsed all these audio files and the text grid files. And then in the next step, the data is normalized. And then lastly, the data is split into test, training, and validation sets. So 22 speakers have been used for the training, one for the validation, and one for the test. Then the next three blocks where feature extraction is the first one. In this one, the raw waveform is converted into a standard 16 kilohertz. 16 kilohertz. I mean, it's a standard that has to be done. And then afterwards, the recording is also normalized. So it means that it has zero mean and unit variance. And then basically this function builds the recordings ready for the wave LM base plus transformer. So this is then fed to the transformer, which basically generates the final embeddings. In total, there are 12 hidden layers in this transformer. However, I take the output of the eighth one because it is believed that the middle layers basically contain the information or the meanings of the phonetics. And once these embeddings are extracted, then they are fed to MLP or neural network classifier, where basically the training is done. And this is a typical training graph for a neural network where you see the blue one is the training one and the red one is the validation one. At this point, I stopped the training because the model was overfitting. And I tried then the model for the test data set, and I got an overall F1 score of 0.79, which in my opinion is not bad. So the final steps then are to give all this information to LLM. This is done in terms of a JSON file, along with, so in the example that we will see, I speak Urdu. It is my native language. So it contains basically the mappings of my language, the phonetics in my language with the phonetics in English to some kind of connection. So it becomes easier for me to improve my pronunciation. And then these things are fed to an LLM, Gemma 3, and then it basically gives us the feedback demonstration now. So this is the Streamlit user interface, where basically once you start it loaded, then it asks that what is your native language? So in my case, it's Urdu. So I say Urdu, and then it says that, okay, based on your native language, I will try to give you a very customized feedback. So there are different options. I mean, principally, there will be different options. So you can either upload your audio or record one. So right now, I don't have these options. However, in the example sentence, I have like preloaded my own audio. So this is the thing that is working right now. So if you go to the record audio, I mean, it will say that it will be there in the future. Then example sentence. So it has now the example sentence. So the sentence that I've recorded is, I'm going to Berlin for a seminar presentation because I don't live in a Berlin. I mean, I live in a different city. So meanwhile, it's doing the analysis. We can listen to the audio. I'm going to Berlin for a seminar presentation. So that's me saying it. And then it will give me the detailed report in terms of the canonical phonemes or the theoretical ones which would have been there and the pronounced ones. So the green ones are fine. The red ones are mispronounced ones. So in total, I made 3 mistakes in this sentence. And now LLM will give us customized feedback. So for the first one where I made mistake in the word M, it tells me that M was expected and it has the same sound as cat word. However, the pronunciation that I did was similar to my. So so there is a difference between these two, and why it happened. It also gives me the reason, because I'm making more rounded vowel than is needed for this sound, and how I can fix this. And it can further be seen for the other two mistakes as well, which I'm not going to go into because of the time constraint. And this is now something even more interesting. So since I'm a native speaker of Urdu language, then it also tells me that for the first mistake where I mispronounced M, how I can try to improve this pronunciation based on the words that I have in my native language. So it also then suggests me these words, which in my opinion, or from what I know, does not exist right now in terms of the solutions that we have. So yeah, this was basically it. And now to conclude, so we saw that this platform was able to uh, do something from raw speech to personalized feedback, where not only it gave me a very general or vague score, however, it also tried to connect the phonetics to my own language. Moreover, we saw that the results that we got was at the very basic phonetic levels, and not some kind of a vague score. Thereby, I tried to close the gap between the two solutions that we saw initially. And for the future work, there's, of course, always room of improvement. However, from what I see, there can be agents associated with the platform, where each agent will give a feedback based on learner's native language. So a different one agent for each language of the learner. And then right now, the suggestions in Urdu that you saw was basically coming from a dictionary that I gave the model manually, because it was only one sentence that I did on my own. However, if it is online, then of course people will say different kind of stuff. And for this, a RAG kind of a pipeline can be associated to the current pipeline. The third thing can be that the response can be more interactive in terms of some kind of a game, or also the pronunciation of the correct phonemes in terms of the audios. And right now, the whole demonstration was only for English language. However, we can also, or I can also try to extend this to different languages. So this was it from my side. If you have any questions, please feel free to ask me.